Hi everyone, Annie here, reporting live from my living room where my toddlers are currently predicting exactly how fast they can destroy this living room. And today we're talking about regression, the statistical kind. Now, regression helps us answer one big question. If two variables are related, can one be used to predict the other? Regression builds directly one correlation, which tells us whether two things are related. Regression goes one step further and asks, if they are related, can we actually use X to estimate Y? According to our lecture, regression always uses two quantitative variables measured on interval or ratio scales, one predicator variable called X and one outcome variable called Y. A great example here is from my life. Hours of sleep will predict levels of parental stress. This is non-directional regression hypothesis because it simply says that sleep will predict stress. It doesn't require us to specify whether it increases or decreases. Our textbook actually uses this kind of non-directional hypothesis for simple regression. In simple regression, we have only two variables, the X, the predicator, and the Y, the outcome, and both must be quantitative and continuous. So ours lab worked beautifully, unlike did my child throw a tantrum, which is definitely not continuous but still predicts many things in life. Next regression uses three different statistical analyses together to test the hypothesis. And this is where I bring my toddlers example, because honestly, regression and toddlers behave the same way. They never rely on just one thing. The first part is correlation. Correlation asks, are X and Y even related? In my house, the answer is obviously yes. As the hours of sleep decreases, my stress level increases as well. The relationship alone is enough to start a regression. The second part is ANOVA, which answers the big question. Does using X actually predict Y better than simply guessing the average of Y for everyone? In other words, is the regression line better than saying all moms always have a stress level of 9? If the regression is significant, it means regression line is a better predicator of Y than the mean of Y. Professor Peter showed us in her example this using those blue and pink lines, comparing the regression predications to everyone is at the average predication. When the regression line constantly gives smaller predication error, ANOVA becomes significant. And then comes the third part, the t-test, which examines the slope of the regression line. The t-test asks, is the slope significantly different from 0? If the slope is 0, X doesn't predict anything. But if the slope is significantly non-zero, it means X truly predicts Y. So if the slope tells me that for every extra hour of sleep, my stress score drops by a certain amount, that slope is doing the predictive work. If the slope were 0, then unfortunately, even full night of sleep wouldn't help, which luckily is not what the statistics says. So summarizing this in one connecting idea, regression uses correlation to see if there is a relationship. ANOVA to check whether the regression line predicts better than simple guessing the average, and a t-test to confirm whether the slope, the actual change in Y for each unit of X, is significantly helping in predication. Regression doesn't tell us about cause and effect, but it does let us make educated predications. And honestly, if I can use regression to predict my toddler's behavior just right now, I will gladly run the analysis. Thank you for listening, and I hope this helps anyone who is struggling with regression. If regression can make sense in the middle of toddler chaos, then trust me, it can make sense anywhere. Thank you.